air inside the Walter E. Washington Convention Center always carries a specific sterile weight during the Association of the United States Army Annual Meeting, or AUSA. It is a peculiar mix of industrial carpet cleaner, stale coffee, and the metallic tang of heavy machinery. At AUSA 2025, the floor was dominated, as it often is, by the titans of the defense industry, showing off their latest main battle tanks and attack helicopters. But if you navigated away from the massive crowd surrounding the Abrams X and the latest rotorcraft tucked into the Oshkosh Defense Pavilion, there sat a machine that was arguably more consequential for the future of American warfare than any 60-ton tank. It did not have a turret, it did not have a cockpit, it did not even have a windshield. It was the Oshkosh XMAV, a designation standing for Expeditionary Modular Autonomous Vehicle, and strapped to its back was a payload that seemed physically impossible for its size, a quad-pack launcher for the Tomahawk Land Attack Missile. The visual dissonance of this system forces you to stop and stare. For decades, the Tomahawk cruise missile has been the heavy hitter of the United States Navy, a weapon system launched from the vertical tubes of Ticonderoga-class cruisers and Arleigh Burke-class destroyers. These are massive warships, floating cities of steel. Yet, here was that same strategic firepower, capable of striking targets over 1,000 miles away, bolted onto a chassis that looked like a headless truck sitting on massive off-road tires. The XMAV represents a violent collision of two competing design philosophies: the extreme lethality of strategic fires and the disposable, low-cost nature of unmanned ground robotics. It creates a central conflict that military planners are desperately trying to solve. How do you project massive power without risking massive capital assets? This vehicle is the physical manifestation of the United States Marine Corps Force Design 2030, a radical restructuring of the service to fight a peer-level naval conflict in the Pacific. The Marines have divested their tanks, shed their heavy artillery, and are betting the farm on small, mobile units that can hop from island to island, sinking ships and vanishing before the enemy can return fire. The XMAV is the tip of that spear, but its mere existence asks uncomfortable questions. Can a robot really be trusted with a $2 million missile? Can a lightweight tactical chassis handle the violent thermodynamics of a Tomahawk launch? And perhaps most importantly, in a war where electronic jamming will be omnipresent, can we control this beast when the satellite links go down? If detailed technical breakdowns of military design and strategy interest you, subscribe. I have got more of these coming. To understand why the XMAV looks the way it does, we have to look beneath the skin, starting with the chassis itself. While Oshkosh calls this a modular autonomous vehicle, the DNA is unmistakably derived from the Joint Light Tactical Vehicle, or JLTV, but with significant evolutionary mutations. The most obvious, of course, is the deletion of the crew cab. By removing the armored capsule that usually protects 4 Marines, the engineers have shaved off thousands of pounds of weight. In a traditional armored vehicle, the crew protection, the transparent armor glass, the spall liners, the mine-resistant seats, accounts for a massive percentage of the vehicle's gross weight. By eliminating the biological cargo, Oshkosh has freed up that weight capacity to be reinvested entirely into payload and mobility. This is not simply a remote control truck, it is a fundamental rethinking of vehicle architecture. The chassis utilizes the Oshkosh TAK4i Intelligent Independent Suspension System. This is crucial because of the weapon system it carries. A Tomahawk missile is a precision instrument packed with sensitive electronics, guidance wafers, and fuel bladders. You cannot simply bounce it over rocky coral reefs or through mangrove swamps on a stiff suspension without risking damage to the bird. The TAK4i system provides 20 inches of wheel travel, allowing the vehicle to glide over terrain that would shatter the axles of a standard logistics truck. This suspension can actively adjust ride height, lowering the center of gravity for stability during transit, or raising it to clear obstacles. Powering this autonomous launcher is a hybrid electric drivetrain, a significant departure from the pure diesel engines of the past. The system likely pairs a high-output diesel generator, potentially a derivative of the Banks 866T, with a lithium-ion battery bank and electric drive motors. This hybridization is not about being environmentally friendly. It is about tactical silence and instant torque. When this vehicle is in a hide position on a contested island, it needs to be able to sit silently for days, running its electronics and thermal management systems off battery power without the telltale noise and thermal signature of an idling diesel engine. This silent watch capability is the difference between life and death in a sensor-saturated environment. When the fire mission comes down, the electric torque allows for immediate acceleration, the so-called scoot after the shoot. However, the engineering challenge of mounting 4 Tomahawks on this class of vehicle cannot be overstated. A single Tomahawk cruise missile, with its booster, weighs approximately 3,300 pounds and measures nearly 21 feet in length. 4 of them, plus the weight of the erection mechanism and the armored canister, pushes the payload capacity of a standard JLTV chassis to its absolute breaking point. This is why the XMAV we saw at AUSA 2025 features a distinctively stretched wheelbase and an additional set of rear stabilizer jacks. The engineers have essentially built a localized launch pad that drives itself. The launcher mechanism itself is a marvel of hydraulic engineering. In the transport configuration, the 4 missile canisters lie flat along the spine of the vehicle, keeping the center of gravity low and the visual silhouette ambiguous. To the untrained eye, or a drone flying at 10,000 feet, it looks like a flatbed logistics truck carrying a crate. This camouflage is its first layer of defense. Upon receiving a launch order, high-pressure hydraulics lever the canister pack to a near-vertical position. This is a critical moment of vulnerability. The vehicle must be perfectly stationary, the hydraulic jacks must deploy to ground the chassis, and the suspension must lock out to prevent the recoil of the launch from flipping the vehicle. We need to talk about that recoil. Launching a Tomahawk is a violent event. The solid-fuel rocket booster ignites with thousands of pounds of thrust to get the missile moving before the turbofan engine takes over. On a destroyer, the gas management system is built into the ship's hull, venting that superheated exhaust safely away. On the XMAV, that exhaust is blasting directly into the ground immediately behind the vehicle. The rear of the chassis is clad in high-temperature ceramic tiles and ablative coatings to prevent the tires and suspension components from melting during the launch sequence. It is a brutal, chaotic few seconds where the vehicle is subjected to immense thermal and mechanical stress. The weapon system itself, the Tomahawk Block 5, is the reason this vehicle exists. This is not the Tomahawk of the 1990s. The Block 5 variant includes a maritime strike capability, meaning it can hit moving enemy ships at sea. This transforms the XMAV from a land attack nuisance into a legitimate ship killer. Imagine a battery of 6 of these vehicles dispersed across a small atoll in the South China Sea. That is 24 anti-ship cruise missiles, hidden in the jungle, capable of saturating the air defenses of a hostile task force. The sheer economics of this trade are terrifying for a naval planner. A multi-billion-dollar destroyer can be threatened by a handful of unmanned trucks that cost a fraction of the price. But this overwhelming firepower comes with a hidden cost that the designers had to grapple with intensely. Targeting. The XMAV is blind. Unlike a tank, which has its own optics to see the enemy, or a destroyer with its massive SPY radar arrays, this vehicle cannot see what it is shooting at. It is strictly a missile hauler. It relies entirely on external data. It needs a target track provided by a satellite, an F-35 Lightning II, or a forward observer. This reliance on the kill web means the vehicle is only as effective as the network that connects it. If the enemy jams the data link, the XMAV is just a very expensive paperweight parked in the jungle. This brings us to the brain of the beast, the Autonomy suite. Oshkosh utilizes a system often referred to as Remotely Operated Ground Unit for Expeditionary Fires, or Rogue Fires technology. The XMAV operates on a leader-follower logic or waypoint navigation. It does not necessarily think like a human driver. It uses LiDAR, cameras, and GPS to navigate terrain. In a convoy, a single manned vehicle can lead a pack of these autonomous launchers like a shepherd leading sheep. This multiplies the force. 10 Marines can now operate a battery that used to require 50. But autonomy in the mud is very different from autonomy in a laboratory. The sensors required for autonomous driving, the spinning LiDAR pucks, the optical cameras, are delicate. In the operational environment the Marines face, these sensors will be coated in salt spray, caked in mud, and battered by tropical storms. If a LiDAR sensor gets covered in wet leaves, the vehicle stops. It lacks the human intuition to say, "That's just a bush, I can drive through it." The software safety protocols are rigid. While this prevents the robot from driving off a cliff, it also means the vehicle can be paralyzed by complex terrain that a human driver would navigate instinctively. Furthermore, the cybersecurity aspect of the XMAV is a nightmare that keeps engineers awake at night. We are talking about an unmanned vehicle carrying high-explosive ordnance that is connected to a wireless network. The attack surface for cyber warfare is massive. Enemy hackers do not need to blow up the truck. They just need to trick its GPS receiver into thinking it is 3 miles to the west, or inject a command that prevents the launch sequence from initializing. Oshkosh and the Marine Corps have invested heavily in hardened encrypted data links. But the eternal race between encryption and decryption is one where the attacker often has the advantage. Let us shift gears to the operational reality of this system, because the spec sheet never tells the whole story. The theoretical capability of the XMAV is impressive: air deployable, autonomous, heavy firepower. But picture the actual deployment. A C-130 Hercules transport plane lands on a rough dirt strip on a remote island. The ramp drops, and this autonomous launcher rolls out. There is no driver to check the oil. There is no crew to tighten the lug nuts. The vehicle is on its own until the maintenance team catches up. Maintenance is the Achilles heel of unmanned systems. A vehicle in the field is in a constant state of decay. Hoses dry rot, seals leak, electrical connections corrode. With a human crew, you have eyes and ears on the machine constantly. A driver might hear a strange rattle in the suspension or smell burning coolant and catch a failure before it becomes catastrophic. The XMAV has health monitoring sensors, yes, but sensors can fail, and they cannot tighten a bolt. The logistical concept relies on expeditionary maintenance, small teams of mechanics flying in to service the robots. But in a high-intensity conflict, those mechanics might not be able to reach the island. We could see a situation where perfectly good missiles are stranded because a $10 relay in the vehicle's transmission failed, and there was nobody there to bypass it. Then there is the issue of reloading. The Tomahawk canisters are heavy. You cannot reload them by hand. You need a material handling crane, a forklift, or a dedicated reload vehicle. So for every XMAV battery, you need a logistical tail of reloaders. If the XMAV shoots its 4 missiles, it becomes a useless truck until it meets up with a supply convoy. This tether to logistics limits the true autonomy of the system. It can drive itself, but it cannot feed itself. The terrain itself is an enemy. The Pacific capabilities of the XMAV rely on it being able to traverse soft sand and volcanic rock. While the TAK-4I suspension is world-class, physics is still physics. A 25,000-pound vehicle on 4 tires has high ground pressure. If it bogs down in a mangrove swamp, there is no driver to rock it out. It is stuck until a recovery vehicle arrives. And a stuck vehicle is a target. This vulnerability to detection is another contradiction. The XMAV is small compared to a ship, but large for a tactical vehicle. To fire, it must stop and erect its launcher, creating a distinct radar and visual signature. The launch plume of a Tomahawk is visible from orbit. The moment it fires, every enemy sensor in the theater will triangulate its position. This necessitates the shoot and scoot tactic. The vehicle must lower the launcher and displace immediately. But how fast can it really move on autonomous navigation through unknown jungle terrain? If it moves too fast, it risks crashing. If it moves too slow, it dies. The algorithms balancing speed versus safety are written in code, but the consequences are written in blood. Knowing what you now know about its performance in the field, do you think the design trade-offs were worth it? Share your thoughts below. Comparing the Oshkosh XMAV to its contemporaries reveals just how unique this American approach is. If we look at the Russian military, their equivalent systems like the Bastion P are manned, heavy, 8x8 trucks. They rely on brute force and heavy armor, accepting the logistical burden of a large crew. The Russian philosophy assumes the vehicle will fight as part of a large, cohesive unit. The American XMAV flips this. It assumes the unit will be broken, scattered, and operating in the shadows. The Chinese People's Liberation Army has developed similar systems, such as the YJ-62 and YJ-12 coastal defense batteries. Like the Russians, these are generally large manned platforms. However, China is rapidly advancing in unmanned ground vehicles. The difference lies in the payload. Most existing unmanned ground combat vehicles are armed with machine guns or small anti-tank missiles, weapons with a range of a few miles. The XMAV is unique globally because it pairs a tactical robot with a strategic 1,000-mile weapon. There is almost no direct equivalent currently fielded that combines this level of autonomy with this class of heavy ordnance. The closest internal competitor might be the Typhon system that the U.S. Army is fielding. But Typhon is a trailer-based system towed by a manned HEM-TT truck. It is semi-static. It takes time to set up and time to pack up. The XMAV is self-propelled and integrated. The tactical agility of the XMAV is superior, but the Typhon carries more missiles per battery and benefits from the reliability of a human crew. It is a classic debate, the reliability of the old ways versus the potential of the new. Another critical point of comparison is the cost of attrition. If a Bastion P battery is destroyed, Russia loses trained soldiers, specialized officers, and a heavy vehicle. If an XMAV is destroyed, the U.S. Marine Corps loses a truck and some circuit boards. The human cost is zero. This changes the calculus of risk. Commanders can send XMAVs into extremely high-threat zones, suicide missions essentially, where they would never send a manned platoon. This opens up tactical possibilities that were previously impossible. You could drop an XMAV on an indefensible rock inside the enemy's weapons engagement zone just to create a threat vector, knowing full well it will never come back. However, we must address the legacy and the long-term impact of this technology. The XMAV at AUSA 2025 is more than a prototype. It is a declaration of the end of an era. For a century, the primary metric of land power was the tank. The tank combined firepower, mobility, and protection in one package. The XMAV unbundles this. It sacrifices protection entirely. It relies on stealth and mobility for survival. it represents a shift from armor to avoidance. This shift is driven by the reality of modern sensor-fused weapons. In a world where top attack munitions and loitering drones can destroy any tank, armor has hit a point of diminishing returns. You cannot put enough steel on a vehicle to stop a modern missile without making it too heavy to move. So the Marines have decided to stop trying. They are stripping the armor off and replacing it with distance and deception. The XMAV is the embodiment of the glass cannon concept, tremendous offensive output with almost zero defensive durability. The integration of the Tomahawk missile onto this platform also signals a blurring of the lines between the services. Historically, the Navy handled deep strike and the Marines handled the beach. Now, the Marines are handling deep strike from the beach. This allows the Navy to keep its destroyers further out to sea, out of range of enemy hypersonic missiles, while the Marines on the inside of the island chain provide the anti-ship firepower. The XMAV is the physical link in this distributed maritime strategy. Yet, as we stare at this machine on the convention floor, we have to wonder about the psychological distance it creates. War is becoming increasingly abstract. A Marine operator sitting in a bunker on Hawaii might be controlling an XMAV on a rock in the Philippines, firing a missile at a ship in the Taiwan Strait. The feedback loop of combat, the noise, the smell, the immediate danger, is severed. This technological insulation protects our soldiers, which is good, but it also sanitizes the violence. It makes the firing of a strategic weapon feel like a video game. The assessment of the XMAV ultimately comes down to the reliability of its software. The mechanical engineering is sound. Oshkosh knows how to build trucks, and Raytheon knows how to build missiles. The weak link is the code that connects them. In the chaos of a near-peer conflict, where GPS is jammed, radios are screeching with static, and the electromagnetic spectrum is a war zone, can the autonomous brain of the XMAV function? Can it navigate the fog of war without a human hand on the wheel? There is also the question of payload flexibility. While the 4-pack Tomahawk configuration is the headline grabber, the modular in XMAV is key. This same chassis could ostensibly carry naval strike missiles, anti-aircraft interceptors, or even loitering munition swarms. It is a universal carrier. If the Tomahawk proves too heavy or too cumbersome for the chassis in real-world testing, the Marines can pivot to lighter munitions without scrapping the vehicle program. This modularity is its insurance policy against failure. The XMAV effectively solves the problem of how to disperse firepower. In the Cold War, we concentrated power to smash through the Fulda Gap. Today, concentration is suicide. If you bunch up, you die. The XMAV allows the Marine Corps to sprinkle lethal power across thousands of square miles of ocean. It turns every small island into a potential aircraft carrier. It complicates the enemy's targeting cycle enormously. They cannot just look for the aircraft carrier. They have to look for every camouflage truck on every single island. But the final resolution of the central conflict, robot versus reality, remains ambiguous. We are placing immense trust in unproven autonomy. The first time an XMAV gets confused by a reflection in a puddle and drives a $2 million missile into the ocean, there will be an uproar. The first time a cyber attack renders a battery inert, critics will scream for the return of human crews. The transition will not be smooth. It will be filled with expensive failures and embarrassing glitches. Despite these risks, the trajectory is clear. The days of the manned, heavy frontline combat vehicle are numbered in this specific domain. The XMAV proves that you can package strategic lethality into a tactical footprint if you are willing to cut the human out of the loop. It is a terrifying, impressive, and inevitable evolution of warfare. It is a machine that feels no fear, ignores suppression fire, and stands ready to deliver a devastating blow from the shadows. Whether it works as advertised when the shooting starts is the billion-dollar gamble the Marine Corps has taken. If you found this analysis useful, a like helps more people discover these deep dives. Thanks for watching.